Today we're going to go over some basics, like very basics of takeovers. Takeovers are going to take a bit of time for everybody to truly learn. There's so many variations in houses and in anybody's different situation that it's going to be difficult to train on every scenario anytime. But we're going to train on something very basic today. Start with that, and then we're going to kind of expand on that through different trainings and different things like that. So I'm going to have you guys watch this video really quick, which is just the very basic introduction to an Alula takeover, but also to just the basic wiring. So very short video. I'm going to have you guys watch this, and then we'll go from there. So you guys go to sleep. Let's see if it's loud enough for everybody.
Can you hear him? The panel choice we're using is a DSC Impasa. This here is the translator. It is the RE508X. So I'm going to show you guys here. We actually have a transformer and the actual device. Here you see all of the terminals, starting with the power, of course, and points for the zones. But the most important part is the actual instructions. This is very important, don't throw it away. So for this example, we're using the DSC Impasa. So we're actually going to go over and select DSC over here. Yeah, we'll show you guys a little more when we actually get into the panel. Don't be overwhelmed by all the wires that are in the box. We're only looking for the ones that are plugged into the circuit board. There's a schematic in place to make it even easier for us to identify what we need. Our goal is to get the wires on the outside of the panel, and most panels that you'll run into, they have grooves inside of the system. If you look up here, you see a circle, and if you take like a screwdriver and dig it through, although it looks solid here, it'll pop right through. In this example, we actually have a hole already prepared here. So the next step is to mount the translator. So before we can actually start taking everything apart, we need to know where we're working at. The closer to the panel, the better. Based on the schematic, zone 1 is 8 and 9. So I'm only going to mess with 8 and 9 for now. I'm going to take out terminal 8 first. Terminal 9. You can pull it through. The resistor is what this is called. On here, it's not needed for the translator.
I don't want to talk about it.
Traditionally, we use red for the actual zone and black for the common. Plug it up.
Oh, it's cool. It's not true.
So we just finished zone 1, right? That's 8 and 9. Next one is 10 and 11. This is zone 2. This is actually the wire for 10. This is the wire for 11. Back to the top again. So we're going to do this one by one, like we talked about before. Same thing from last time. If you see the resistor on it, that's the resistor off. Strip the wire. So both of the blacks go into the ground. And now it's time to and then we finish up number 2, pushing it into its right terminal. Most systems only have 8 zones on the side. I'm going to finish this up over here, and then we'll go to the next step. Learning hardware zones into the Impasa. This is the finished product. We actually had 6 zones to translate, so they're all. The random power line, of course. Translator is DSC. Make sure all of the doors and windows that you're using is closed. So first of all, this button here. Until the noise stops. Close up to the keypad and try to play with this. Okay, so now we're in programming. We're going to go into wireless enrollment mode. Section 8, 9, 8. Go to the door. Star. Now, the first zone in the hardwire system is traditionally the door, so in zone 1, that's all the info we're running for. We're going to test the device and make sure that it is fine. Alright, that's all there is to it. I hope this is helpful. Thanks for watching.
Alright, so what do we think, other than I don't even know what this is now? So what do we think of that one?
So you don't need resistors for the Alula?
Exactly. Beyond that, I was looking into resistors, which we'll get into. Sorry, yeah, this is multiple displays. I was looking into because David actually mentioned it, was asking me a question about resistors and why and what they're used for, and I didn't have a solid answer for it. So here, I'm next to for today.
Did it come through?
IDI-wires.
Did it come
So
through?
Michael
I have
from
no idea.
Wire.
My phone service is
Today,
shut off, so
I'm going to be
see
talking
any
about
emails.
converting a wired alarm system into a wireless alarm system. So the most common reason will be
All right, so
Like you need a company phone.
the reason for resistors is mainly to prevent shorts or to let you know there's a short in the system. So, but they have to be wired right. So all the time when you guys go to a panel and you see the resistor in the panel, it does you absolutely no good. It's literally useless. No matter what happens, it does you no good. So no need to do that whatsoever for any panel. I think it's required on a Qualsys takeover, the actual IQ takeovers. We'll double check though if we can bypass that, because again, if you wire them in the panel like that, like you see in a lot of houses, it does you absolutely no good. It has to be on the end of the end of line device, just like in a fire system. Otherwise, it does no good, because what it's doing, and we'll go into this a little bit more another time, is the current is going to the devices and then coming back to the system. If the system shorts out, if the wires are touching before it gets to those sensors, the system thinks the system's closed even if the windows are open or whatever else. Now with a resistor, it's looking for that resistance. Now if the resistor's right here at the panel, even if it shorts out, the system's actually gonna be closed because that resistor is gonna be there. But if it's looking for the resistor and it's up by the device and it shorts out right here, and it goes to the path of least resistance right here, it's actually going to, it'll say that there's an issue with the system, so that it pretty much say that the line is open or shorted. So it's a preventative measure, but if you see them in the panels, you can take them out. So